Today, we are going to have a lot of fun. What we are going to do is we are putting everything we've done in the last week and smashing it all together in one lesson. Sounds exciting. So, we are going to do 1.6. We're continuing this. And what we are actually doing are absolute value inequalities. So we're doing everything we've been working on for the last week, week and a half, smashing it all into one lesson. Okay. Absolute value inequalities are compound, which means when we say compound, that's both and or, right? So let's start there. If I have the absolute value of A less than or equal to, it could be either one, of B, because it is less than, it is going to be an and problem. If it's an and problem when we graph it, remember, it is sandwiched in between two endpoints. Which also means if it's an and problem, it is going to have interval notation from one endpoint to another. Option number 2 is if I have the absolute value of A is greater than or equal to B, that's going to be an or problem. And if it's an or problem, that goes in opposite directions, right? And the interval notation will be negative infinity to a number, a u, that number to infinity. Those are going to be your two options when you're working with an absolute value inequality. So just like when we were working with equations, you have to first get the absolute value by itself. Same thing here. Then, once you get the absolute value by itself, you're going to take what's inside the absolute value, and you keep the sign to B. The second one, however, is you keep what's inside the absolute value, you flip the sign and make it a negative B. We're going to do the same thing down here. The first one, as soon as the absolute value is by itself, we have A. We keep our sign greater than B, or we're going to have A, flip the sign, negative B. Yep. Flip the sign and make it opposite. Yep. So that's the only thing that's different from yesterday is now we have an inequality sign instead of equals, right? And we just flip it at the same time as we make it negative. The other wonderful thing is now we get to graph again. And if we graph, that means you have to do interval notation. Exactly. Okay? So exciting. Here we go with example number 1. So let's say I have the absolute value of x plus 3 is less than or equal to 7. So looking at this right from the beginning, is the absolute value by itself? Look at the sign. Is this going to be an and problem or an or problem? This is going to be an and problem. Very good. So you should already have a picture in your mind of what it should look like when we get done, right? Okay. So let's set it up. Since the absolute value is by itself, we can set up the first one as x plus 3 is less than or equal to 7. The second one, now I'm going to write and in the middle to help us remember this is an and problem. X plus 3 is greater than or equal to negative 7. Flip the sign, make it negative. Okay? So now let's solve both. Over here, if I subtract 3 to the other side, I get x is less than or equal to 4. Over here, if I subtract 3 to the other side, I get x is greater than or equal to negative 10. I know it is. If we graph, let's start at 4. I have a closed dot, and it goes to the left. Over here, I have x is greater than or equal to negative 10. So at negative 10, which is on this side, make sure you put the number on the right side, okay? We have a closed dot, and this goes to the right. That is an and problem, isn't it? Interval notation. We start at the closed dot, which is a bracket. Negative 10 to 4 with a closed bracket. So is this any harder than yesterday? No. Really? Really, really? Let's do example number 2. I don't know. Example number 2. Let's say I have 2 times the absolute value of 2x plus 4 is greater than 12. Is the absolute value by itself? So what do we got to do? Good. Divide by 2. Whoops. Divide both sides by 2. So I get the absolute value of 2x plus 4 is greater than 6. Now, that the absolute value is by itself, is this an and or an or? This one's an or because it's greater than, right? My first equation, 2x plus 4 is greater than 6. The second equation is what, Irene? Yep, perfect. Less than negative 6. Now we're going to solve them both. Solving this one, I'm going to subtract 4 to the other side. I get 2x is greater than 2. So x is greater than 1. Over here, I'm going to subtract 4 to the other side. I get 2x is less than negative 10. Dividing both sides by 2, I get x is less than negative 5. On a number line, x is greater than 1. Open or close dot? Open, and it goes which way? X is greater to the right. Good. Where does x is less than negative 5? Where's negative 5 on my number line? It's over here, isn't it? On the left. Thank you, Jacob. So I have an open dot at negative 5, and this one goes to the left. Is that an or problem? Yes, it is. So we have negative infinity to negative 5. A u, 1 to infinity. Questions? How we doing? We're doing okay? Good. Good, good, good. Just a little bit, not much. All right, how about example number 3? Let's do another one. Gabe, my man. You ready? Okay. All right. Let's go with 3 times the absolute value of x plus 1 minus 4 is less than 5. Is an and. Correct. So first we have to add 4 to the other side. So we have 3 times the absolute value of x plus 1 is less than 9. Now what do we do? Good. So we have the absolute value of x plus 1 is less than 3. And because this is less than, it is an and problem, right? All right, first equation, or inequality, is x plus 1 is less than 3. The second inequality Gabe is what? Good, thank you. Now we'll solve them both. Over here, I'm going to subtract 1 to the other side, so I get x is less than 2. Over here, I'm going to subtract 1 to the other side. I get x is greater than negative 4. Very good. On my number line, at 2, I have an open dot, and it goes which way? To the left. This direction. At -4, which is over here, I have an open dot, and this one goes to the right. Interval notation this time. Parenthesis, -4 to 2 with a parenthesis. Timmy, why did I use parentheses? Correct. They are open dots. I agree with you. Questions, you guys? How are we doing? This is not too bad? Okay. I only have one other thing that I want to talk about. No. We're going to play with that afterward, but just about. All right. Here's the other thing I want to talk about. Is you have 3 problems where you are going to have to write the absolute value inequality from the answer or from the solution. So it's going to ask you to go backward with it, okay? So here's how it works. All right? We're going to use an absolute value, x minus, and I'm going to put a C here. This C represents the middle number, okay? Then my sign here is less than or equal to. And on this side, it's going to be another number. Now, this number is the distance from the middle to either end. Just a minute. Not as bad as you think it is. Okay, so here's how it goes. Well, just a minute. Just a minute. So, if I give you the solution, for example, 10 is less than or equal to x. Yes, just a minute. Less than or equal to 20. And I want you to write the absolute value inequality that will give us that solution. Okay? So we start with the absolute value, x minus. What is exactly in the middle between 10 and 20? 15. So that goes here. Then we put less than or equal to, same sign that's in our answer. And how far is it from 15 to either end? 5. That's all we're doing. Well, if we solve for it, it would take you back to that answer. So think about it. If I set that up, I add 15 over, I get x is less than or equal to 20. Isn't that answer right there? If I flip the sign and make that negative and I add 15 over, I get x is greater than or equal to 10. Isn't that solution right there? So that's what we're doing. Let's do one more. Sure. Sure. What do you need, Irene? Okay. So, example number 4. When you are doing your homework, this is going to cover numbers 38 through 42. This is what you're doing. Write the compound inequality. All right. 4. Say I have 4 is less than or equal to x less than or equal to 22. Yes, there is. Yep. So here we go. We have the absolute value, x minus. Exactly halfway in between is what number? 13. I agree. Less than or equal to. How far is 13 from 4 or 13 from 22? It is 9. That's it. So how did you get the middle number? You took the ends and added them together, divide by 2. Okay? Yeah. All right. Any questions? Yeah, 22 plus 4 is 26, divided by 2, 13. Okay. Time to find the average, right? All right. So I talked for exactly 15 minutes. I expect you to use the next 12 to start this so I know that everybody is understanding. You are very welcome. Yeah, you got it. All right, so I want to see you guys getting started. Uh-huh. No, why? I know, but now we're doing even. I'm sorry. If you want to do it, you can.